Our project was to design a launcher in coordination with Framework Automation for their toy glider. So we had to go, first of all, design a launcher for their glider and then have it designed in such a way so that it could be automatically assembled by this robotic assembly cell. Various dispensers for the robot to come and pick its parts and then assemble them here on the line itself. The biggest thing that we've learned during the project quarter has been to work as a team, because without all this teamwork we wouldn't have been able to pull all this off. If it wasn't for my friend Zach here, we wouldn't have been able to get the spin dispenser, get all this stuff working, all this laser cutting. I mean, it takes so much manpower and you can't just have one person do all this. So we had to work together and get it done, and that's what we did. The end product is this launcher right here. Most challenging part of the project would have been first of all designing this so that it could be automatically assembled, and then this isn't the first iteration. We've had to design this at least 6 times. But the second hardest part was getting all of these electronics to work, because we're mechanical engineers and we did have training in this, but a lot of this is still new to us, so we had to train on the go as we were doing the project. But everything seems to be working, so we're happy.
I'm one of the team members of Framework Automations. I have 2 other team members that have been working for the last 3 months on this robotics assembly station. What the robotic cell does is it keeps everything in place and pushes everything into place. We have the assembly bay. That's where everything gets put together. We have the 3 dispensing stations. This is the body dispensing station. Underneath and loadable is the wing station and the tail station. These particular points will keep the plane in place, the body in place. So every time the robot comes over, it's going to be able to pick up from exactly where it left off the last time. Same thing for the wings. The wings will be pushed out, but they're always kept in the same position. We've made sure that everything lines up. The doors are there to keep fingers out of the way while it's being constructed. We've got some fairly sharp pieces in there. We don't want anybody to get hurt. That would be bad. We're using servos, we're using electronics, we've got pneumatics, we've got a whole pile of neat stuff going on here, including the robotic arm, which is the centerpiece. If you don't design your parts right, if you don't design how everything goes together perfectly, it's not going to work. And it takes a lot of time to do the design, but if you get it wrong, it takes a lot more time to fix it.